my name is Phil and I'm here with my partner Emin, both students from the University of the Philippines Open University. Today's discussion centers around shedding light on explainable artificial intelligence or XAI. While we will touch on the fundamentals of XAI, our primary focus is on providing a concise explanation of this fascinating field and delving into the nuances of intrinsically interpretable methods. To outline the structure of this presentation, we will begin with a concise overview of XAI followed by an exploration of the broad categorization of XAI methods, with a specific emphasis on intrinsically interpretable methods. Finally, we will conclude with key insights gleaned from the entire presentation. So, what is XAI? Explainable Artificial Intelligence objective is to make the inner workings of AI more accessible to humans, promoting a clearer understanding of how and why certain decisions are made. It also focuses on creating AI system that offers understandable explanation for their decision, aiming to empower users to comprehend the reasoning behind specific choices. This development is crucial for enhancing transparency and trust in AI, particularly in sensitive sectors such as healthcare, finance, and criminal justice. So, why is it important? XAI is crucial for understanding decision-making process, identifying biases and revealing errors in complex machine learning models. It addresses opacity and lack of transparency, particularly in critical sectors like healthcare, finances, and legal system. XAI promotes fairness, debugging, and responsible AI deployment, emphasizing the importance of understanding AI-generated outcomes for trust, accountability, and ethical standards. What are the challenges addressed by XAI? Well, the challenges XAI include deploying complex machine learning models effectively, minimizing biases during training to ensure fairness, achieving transparency in decision-making process, and lastly, providing interpretable explanation for AI decisions. Addressing these challenges isn't needed to integrate and accept XAI successfully to ensure AI systems are accurate, efficient, trustworthy, and accountable in real-world applications. On the next part, Emma will be discussing how XAI works.
In the next part of our presentation, we will answer, how does explainable AI even work? According to a study by Doshiveles and Kim, explainable AI methods can be broadly categorized into three kinds. First are the intrinsically interpretable methods. Second, example-based explanation. And third, model-agnostic methods. In literature, other methods are outside these classifications because they can't be classified under only one or the three broad kinds. But that's for a different topic. In this presentation, however, we would like to focus only on one broad category of explainable AI, which is the intrinsically interpretable methods. But what is an intrinsically interpretable method? Try to imagine a magic guessing box, quite similar in concept if you've owned a magic 8 ball before, but intelligent. So these methods are primarily like a special magic guessing box, special because they are good at telling us why they make certain guesses. When you ask your magic box a question, it doesn't just say yes or no or a non-committal statement like your magic 8 ball. Instead, it explains how it figures out the answer. So imagine a person named Steve. Steve is a fine young man with a peculiar personality and sexuality, and he asks our special magic guessing box a question: will I ever have a girlfriend? The magic box processes the statement and returns an answer. No, Steve, because you're 100% gay. It's like having a friend who gives you the correct answer and tells you exactly how they found it. You might have previously encountered these methods in your high school or university statistics classes. Examples are linear and logistic regression. Hope that rings a bell. And generalized linear and additive models. If you've been delving into AI for quite some time now, you might also be familiar with decision trees, naive Bayes, and k-nearest neighbors. Of course, this is not an exhaustive list, but other methods still fall under this category. Each method has its own way of making predictions, but they all aim to help us understand and predict things in different situations, like Steve's magic guessing box. All of these can be found in every industry. The endless possibilities can have multiple applications in healthcare, mining, telecommunications, logistics, and many others. Now, let me share a personal example which my former team did in a DOST funded project with the Philippine Department of Health. The goal was to explore an EMR database because they wanted to know what we could do with it. As part of our exploration, we performed a logistic regression analysis and looked at the significance of demographic variables versus hypertension diagnosis. As you can see on the right side, we show the logistic model's performance should other patients be misdiagnosed, assuming the model performed well. Unfortunately, that was not the case, so we asked why. Various metrics, including demographic variables significance, variability, outcome association, and model performance in terms of accuracy, all of which led to the insight that the model can only interpret 18% of the variability. This is because while the demographic variables have shown a significant association with hypertension diagnosis, it is not sufficient to explain the combined effect of all coefficients to interpret the variability of hypertension diagnosis at an acceptable level. Other data, preferably patients' behavioral and metabolic risk factors, may also be needed. Like any other method as shown in the earlier example, the results sometimes could be unappealing because each has its pros and cons. As observed in our earlier example, intrinsically interpretable methods are transparent, intuitive, and can reduce overhead. The trade-off, however, is that because of its simplicity, there is limited power of representation. It could also be less adaptable to variation, and more importantly, while it excels in interpretability, its simplicity comes at the cost of predictive performance. So let's try to recap now what we've learned so far, okay? The first key takeaway is that explainable AI ensures that the processes behind AI predictions are transparent, helping humans comprehend, validate, and trust the system's outputs. And the second, simplicity makes it easier for people to figure out why the AI made a specific decision, promoting transparency without needing additional complicated explanations or tricks. Therefore, the importance of explainable AI for responsible and trustworthy AI development lies in its ability to enhance transparency, accountability, and ethical standards in AI systems. Hope that helps, and that ends our presentation.
Thank you for joining us on our presentation about explainable AI. We hope that you've gained valuable insights into this complex subject. Once again, we express our sincerest gratitude for your time and engagement, wishing you all a joyful holiday seasons filled with merriment and prosperous new year. Once again, thank you. Bye.